Yes, good morning, friends. Welcome to the session once again. Okay, today, as you know, we are going to conduct the fourth session. Okay, in fact, the fifth session. Okay, fifth session of Oceanography. We have already covered four sessions. The session is consists of 40 minutes, so we have already covered four. Today is the fifth session. Clear? We will begin our discussion from where we have left yesterday. I hope my audio and video is working fine. If in the middle of discussion, if you are not able to follow any points, you can interrupt me at any time. You can do so in the live chat box below. Okay, because it is the only way by which we can communicate. Clear? And in this particular session, we will be taking up only the broad aspect. Okay, in a very broad manner only we will be discussing. We won't be able to discuss everything in detail because of paucity of time. I already told you, if you are interested, you can always come and join me in my Plus course in the Unacademy platform. There we discuss everything in detail, and also at the same time, as you know, we have more facility of interaction, and also the tools are much better in the Unacademy platform where we can interact very efficiently. Clear? Anyways, before we begin our discussion of today, let me just give you some information from the Unacademy platform. Because of the popular demand, the price hike was expected on 16th. Actually, it was supposed to be on 16th of December, but because of the popular demand, it has been extended till 23rd. 23rd is tomorrow. Okay, so you only have one day left. Therefore, you have this plus Compose subscription plus GS subscription. You kindly subscribe to this if you haven't, to take the benefit of a huge discount that you will be getting. On the other hand, if you go for this 1 year and above subscription, you will get 3 months extension. 3 months is a very long time. 90 days. Okay. Also, you see, today these courses are getting started. Your prelims is there in the month of June 2022. Hardly 6 months. Therefore, taking that into consideration, the Unacademy platform comes up with this comprehensive batch courses on GS, Mission 2022 or Lakshya 2022. Similarly, if you're in your roadmap, if you are planning to sit for 2023, you can still go for Mission 23 and Lakshya 2023. Okay, it is also both available in the platform. Clear? It is starting from today. So don't wait for anything. Kindly go ahead. You will also get 20 GS book curated as per the latest UPSC trend. Okay. Now, nothing like practicing for your prelims as well as revising on whatever topics you have already discussed with the MCQ, that is multiple choice question. Taking that into consideration, in Unacademy platform, absolutely free, you have this free test series. The recently introduced, already one session has been conducted. It is a Mrunal's Monday. Okay, here 20 MCQ in 20 minutes. It is available both in English as well as in Hindi. Timing is every Monday 8 p.m. So the coming Monday also it will be there. Okay, coming Monday it will be, I think, 27th of December. Similarly, we have this D20 current affair and also Abhiyan, that is the static part. Both are 15 MCQs in 15 minutes. Both is available, it's in English as well as in Hindi. Timing is different, you kindly note. T20 daily current affair test series is 7:30 p.m. On the other hand, this Abhiyan, that is the static portion of your different subject like polity, economy, so on and so forth, it is Monday to Friday 10 a.m. Okay, you can use my code for your enrollment, that is SUNEP10. Clear? Chalo. With that, let us continue our discussion today also. Yesterday we have seen the salinity characteristics of the ocean. How salinity varies horizontally as well as vertically. We have seen different scenarios. Yesterday we have seen the thermocline layer. the pycnocline layer, and also in different latitude, what will be the salinity? What are the factors that determines the salinity? And also at the same time, we have seen the nature of the ocean current and ocean wave, which influences the salinity of different region. Also, we have seen the example of how the orientation of the water body determines the salinity. We have taken the example of Red Sea, where the opening of the sea or opening of any water body to the oceanic circulation is very, very small, very, very narrow. Salinity tends to be higher, okay, compared to the salinity of the open ocean in the same latitude. Similarly, the orientation, like say for example, Gulf of California and Mediterranean Sea, they are almost not exactly at the same, but almost in the same latitude. But the salinity will be much higher in the Mediterranean. Why? Because it is oriented east to west, not or west to east. On the other hand, Gulf of California and all, they are oriented north to south or south to north. And because of this, the salinity will vary. Okay. Since we are discussing the characteristics of the seawater or ocean water, okay, you kindly follow the systematic approach that we are following in the session. First, we have seen the ocean bottom topography. After that, we have seen the different ocean, like the Indian Ocean, Pacific Ocean, Atlantic Ocean. After finishing that, we are now studying the ocean water or the sea water characteristics. In this, we have seen there are dissolved particles, substance, suspended substance. Under this dissolved, there are minor, major. We have seen different gases, different nutrients. After this, we are seeing the salinity and temperature characteristics of the ocean water or the sea water. After this, we will go and see the oceanic deposit. See, that is how step by step we are going, step by step, in order to have a proper understanding of the oceanic ecosystem. Okay, yesterday we have seen the salinity. Today we will see the temperature distribution in the ocean. What factor determines the temperature distribution in the ocean? Okay, first is albedo. What is albedo? In a very simple sense, albedo is the reflectivity index, you can say. Whenever any kind of sun insolation is there on the surface, depending on the nature and characteristics of this surface, it is reflected back. The efficiency of this reflection is nothing but the albedo. Now, you see here, if a sea is very calm, okay, if the ocean water is very calm, whatever the sun insolation will be there, the reflection will be efficient, therefore more sun insolation will be reflected back. On the other hand, if the sea is very rough, like this, okay, very rough, whenever sun insolation will happen, reflectivity will be less. Why? Because there will be re-reflected waves, sun insolation like this, okay. Multiple refraction will take place here. Therefore, all in all, the albedo will be less in a rough sea as compared to a calm sea. Depending on the albedo, the temperature of this particular region will be determined. Therefore, whenever, depending on the nature of the surface of the ocean, the albedo is determined. Depending on this albedo, temperature will be either less or more in this region. Clear? Second important factor about oceanic or seawater temperature is salinity. Higher the salinity you see, higher will be the boiling point. So in a region where you have higher salinity, the region will have or will experience higher temperature. Local weather condition is also important for influence of oceanic water in this region. Okay, one of the local weather, you can say the different kind of breeze or different type of oceanic current, so on and so forth. Now, cold current is also another influence, or hot current is also another influence. Okay, why? Because whenever there is an ocean current or oceanic circulation, it carries water from one latitude to the other latitude. If the current is going from lower latitude, that is equatorial region, towards the higher latitude, warm ocean current is carried to that higher latitude. If the oceanic circulation is from polar region towards the equatorial region, then the cold water is brought down to the lower latitude from the higher latitude. So that is how a temperature, because of this current, or upwelling or downwelling. Upwelling, downwelling. Say for example, whenever there is upwelling, what is upwelling? Upwelling is whenever oceanic water comes out from bottom towards the surface, it is known as upwelling. Whenever the ocean water goes below like this, it is known as downwelling. Whenever there is a upwelling which is taking place, a cold ocean water from the ocean bottom or from the lower region of the ocean is brought to the surface. So this region will become cold area. One simple example, let me tell you. If it is a land area, if it is a ocean area, if the wind is blowing away from the land like this, whenever a wind is blowing like this, a vacuum is created here. In order to fill this vacuum, a water from below will come up. Therefore, a cold water will come up, therefore influencing the oceanic temperature of this particular region. That is upwelling. Okay, ocean circulation I have already mentioned to you. Factors controlling the mixing of the ocean water. Say for example, similar to the salinity. Okay, example Red Sea, Persian Gulf, Gulf of Mexico. Factors controlling mixing of ocean water, in a sense, you see here. Whether the water body is in a very confined region, the opening of that water body to the main ocean region is narrow or it is open. Say for example, Red Sea and Gulf of Mexico, which one will have more temperature? The Red Sea area will experience more temperature even though they are in the same region. The reason is very simple. It is confined but it is open, Gulf of Mexico. Okay, therefore better circulation, better mixing in the Gulf of Mexico as compared to the Red Sea. Why? Because Red Sea is kind of confined. It has opening, but the efficiency of mixing is less in the Red Sea. Therefore, more temperature, clear. Latitudinal and longitudinal extent. Say for example, the Gulf of California and Mediterranean, how it is, you see here. Kindly follow the pointer, you come here. This is a Mediterranean Sea. This is a Gulf of California. Okay. This is Gulf of California and Mediterranean Sea. Okay, you see here. This is Gulf of California here. This region is represented by this one. This is Mediterranean Sea. They are almost, you can say, in the same latitude. Now, broadly we consider, like as per the different latitude, the temperature will be different. Okay, like higher temperature near the equatorial or tropical region, the more I go up towards the tropic, temperature will reduce. That is the general characteristics. Local effects are there, okay, because of oceanic circulation, but generally, mark my word, generally. In general, we consider the temperature of the ocean water also zonal in characteristics. Means in the equatorial or tropical region, temperature will be higher. Why? Because of the apparent location of the sun insolation. But you see here, where will be the temperature of the oceanic water more? In the Gulf of California or in the Mediterranean region? Even though they are in the same latitude, in the Mediterranean region, temperature will be higher. Why? Because its orientation is like this. But this orientation is like this. Therefore, larger extent of the water body is in the same region, which is near to the tropical region or in the tropical region. But this Gulf of California, yes, it is also in the same, almost the same latitude, but its orientation is longitudinal like this. Therefore, this water body will have lower temperature as compared to this. Therefore, that is nothing but the latitudinal and longitudinal, means the orientation of the water body. Okay, and this is the factors controlling mixing of the ocean water. You see here, Red Sea, Gulf of California, almost in the same latitude, but this temperature will be much lower as compared to this. It is confined. Okay, means there is an opening, but the opening is very narrow. Okay, clear? Now, horizontal distribution of temperature, you see. Just now I have mentioned to you, Horizontal distribution of temperature in the ocean water, we will consider it as a function of latitude. More towards the equatorial or tropical or lower latitude, it will have higher temperature because of the sun's location. Lower temperature in the polar region. Okay, now that is the general characteristics. But one important observation regarding the horizontal, see, very important, horizontal. Okay, vertical we will see later. Horizontal distribution of temperature of the ocean water is the general characteristics I have just mentioned to you. Now, another important observation is seasonal range is widest in the middle latitude. Seasonal change near the equatorial region, seasonal change near the or in the polar region is less. Why? Because over the equatorial region, yes, there is an apparent shift of the sun insolation. During summer, it goes up towards the northern hemisphere. During winter, it comes down to the southern hemisphere. Yes, we know there is a apparent shifting of sun insolation. But whatever the case it may be, it is always near to the equatorial area. Therefore, the sun is always over the horizon towards the equatorial region. Therefore, the variation of the seasonal variation of the oceanic temperature is not much. On the other hand, the polar regions are always in a very cold location because of the less sun insolation in these regions. Therefore, the maximum variation, horizontal variation of the oceanic temperature seasonally, it is maximum in the temperate latitude or in the middle latitude. Okay, seasonal variation or seasonal range in the oceanic temperature is widest in the middle latitude. Clear? Now, that also mostly in the northern hemisphere. Clear? Now, let us see the vertical distribution of temperature. Yesterday, we have already seen during our salinity, either you can call it thermocline if you are taking the temperature characteristics, or we have already seen, that is the pycnocline if you are taking the density parameter. Yesterday we have already seen. Now, for the vertical temperature distribution of the ocean water, we will have to take as per the region, as per the zone. The first one is the low latitude, that is near the equatorial region. Second one is the middle latitude. The third one is the high latitude, that is in the polar region. Vertically, from the surface of the ocean, if I go below, what is the characteristics that is displayed? Now you kindly follow here. In the lower latitude, that is near the equatorial region, on the surface, the temperature will be like this. Now, the moment I come down, if I go towards the bottom of the ocean, yesterday we have already seen, and I have already explained the reason also. Therefore, today I am not going to explain this because we have many more topics to be covered. Therefore, the moment I come down, after some depth, there is a rapid change or rapid rate of decrease of temperature which will happen very, very rapidly. Therefore, we have seen yesterday this is thermocline, right? Thermocline layer or pycnocline layer. It is observed in the lower latitude, that is near the equatorial region. After a point, yes, the reduction in temperature will be there, but the rate of reduction will be very, very gradual and it will come down in this manner. So this is the temperature characteristics of the ocean water vertically. From the surface of the ocean, if you go down towards the bottom of the ocean. Now, in the middle latitude, what is the characteristics? In the middle latitude, the characteristics is like this. This straight line, kindly follow the pointer. It is a summertime characteristics, vertical temperature distribution characteristics in the summertime, in the middle latitude. You see here, it will come down, the higher temperature here, it will come down. Here also, thermocline layer will be there. Therefore, rapid rate of decrease of temperature from here, it will come down like this. But during winter, in the middle latitude, it is represented by this dotted line you see here. Why? Because we have already seen in the horizontal distribution of temperature, that the temperature variation in the middle latitude is maximum depending on the season. Therefore, in the middle latitude, you see here, in the winter time, the surface temperature is this much. Therefore, it will reduce, rapid reduction will happen, thermocline layer again, but in the summer, temperature is high, the surface temperature. In the winter, it is low, and it is shown by this particular graph. If you come to a polar region, you see here, the graph is somewhat like this. Increase in temperature happens after some depth from the surface. Why this increase in temperature is happening like this? Because from the lower latitude, a warm ocean current is pushed towards the polar region. Because of this, just beneath the surface, there will be an increase in the oceanic temperature, but after some time, again, it will reduce and it will come down in this manner. So, the vertical distribution of temperature is analyzed by taking different latitudes, lower latitude, middle latitude, and the high latitude. Clear? This is the temperature characteristics of the sea water or ocean water. Okay, vertical as well as horizontal we have seen. Now let us quickly go and see the other important, one more important topic, that is ocean deposit. Okay, ocean deposit. You see here, ocean deposit. See, let me tell you once again. You kindly follow the step-by-step approach that we are taking. Okay, we are trying to see what is our ultimate objective in oceanography, in order to understand the ocean ecosystem. And in ocean ecosystem means everything, the landform, the properties or the characteristics of the ocean water, and what is there. We are going to see step by step. Circulation also we will see. Okay, now another important topic is ocean deposit, the deposit that you will find in the ocean ecosystem. Clear? Now let us go and see this ocean deposit. What is this ocean deposit? Most of the ocean bottom is covered by the sediments deposited, brought in by rivers. Okay, it can be rivers, it can be glacier, or a wind. Okay, or a wind, along with, okay, see, sediments deposited, brought by rivers from the land area, by glaciers from the land area, by wind from the land area, or it can be the shell and skeleton of marine organism itself, which is there in the ocean. Only a few areas are devoid of ocean sediment. Yeah, only a few areas are devoid of ocean sediment. Otherwise, in all the ocean floor, you will find ocean deposits. The thickest sediments are found near the continent. Thickest deposit of sediments you will find in the near the ocean, near the continent area, especially in the marginal ocean basin, where ridges do not allow the transport of sediments into the main ocean basin. On the basis of the source of origin, like I have already mentioned to you here, it is from land, it is from marine organism itself. So, based on the origin, from where this particular sediments is coming, forming this ocean deposit, if you consider or if you want to classify the ocean deposit based on the origin, it can be classified in this manner. You see here. Number one, the type of the sediment is known as terrigenous. What is this terrigenous deposit, ocean deposit? Terrigenous ocean deposit are known as terrigenous because they are usually from the land area. That is, the source region is, this column is a source region, either erosion of the land, either because of volcanic eruption, or either a dust been blown from the land area. Examples: quartz, sand, clay, estuarine, mud. See, this table is very, very important. Kindly try to remember this table. Distribution. Where this particular terrigenous deposit from the terrestrial area will be deposited where? In which region of the ocean? It is dominant on continental margins. Continental margin continental shelf and continental slope, they are continental margins. Abyssal plains, polar ocean floor. Now, what is the percentage that it covers in the ocean as per the ocean deposit? It covers around approximately 45% of the ocean deposit consists of this terrigenous. Then come the biogeneous sediment type. What is this biogeneous? These are the organic. The source region is the organic. That is accumulation of the hard part of some marine organism. Means from in the ocean ecosystem itself, the organism which is present there, after they die down, they decay, the hard shell particle go on to form this particular biogeneous deposit. This biogeneous deposit can be of two types, calcareous as well as siliceous, and it is known as ooze. Okay, why it is called as ooze, we will discuss later. Where you will find this biogeneous deposit, it is usually dominant on the deep ocean floor. Calcareous you will find on the upper region, siliceous ooze you will find below. The mechanism of this we will discuss later. Now just we are classifying. What is the percentage? See, it is in a deep ocean floor, okay? Remember the distribution. Terrigenous, since it is a land based, it is going from the land area, they will be distributed more next to the land area. Next to the land area is continental shelf and continental slope or abyssal plain. This biogeneous deposit, since they are from the marine organism, they will be found in a deep ocean floor. Clear? What is the percentage? The percentage is 55% of the ocean floor, or as per the deposits, they consist 55% approximately. The next is hydrogeneous or oceanogenic sediment type. What are they? What are the source region? It precipitation of the dissolved minerals from the water, often by bacteria or some other reasons also. The ocean water we have seen yesterday. In the ocean water, what was the characteristics? What are the material which is there in the ocean water? We have seen yesterday, or a couple of days back. We have seen major and minor, dissolved one, suspended one. So the dissolved material which is there in the ocean water, okay, if you are watching the video for the first time, you kindly go and refer to the previous video. Okay, I think the part 2 or part 3 you will find there. The dissolved material which is there in the ocean water will be precipitated out, means will be given out. Example, let me tell you one thing. The salt which is dissolved in the ocean water, when this ocean water is harvested and kept in one place, okay, like the salt farming, the water will evaporate, leaving behind the salt. Means the salt is getting precipitated out in the process of evaporation. Similarly, there are dissolved material. What are the dissolved material? We have already seen. This will be precipitated out from the ocean water itself. That is known as hydrogeneous sediment type. The origin is from the ocean water itself. Example, manganese nodules. Don't worry about this. We will discuss in detail. Phosphorites deposit. Distribution. It is present with more dominant sediments. Okay, they are mixed with other more dominant sediments. Why? Because their percentage is only around 1%. Means very, very less. The final sediment type is cosmogeneous. Cosmogeneous are from the outer space. Whenever there is any kind of meteorites that reaches the oceanic water and become a part of the ocean ecosystem, it is known as cosmogenic type of oceanic sediment. Example, tektite spheres, glassy nodules. Distribution, mix is a technical network issue. I have tried to reconnect myself. Let me just wait for a minute. Okay. Okay, I think now we are back. Okay, you see here. Kindly follow the pointer. This is Equatorial Region, 0 degree. this is the higher latitude, okay, like polar region you can assume here. Now you see, maximum amount of sand will be found in this latitude, okay. Why? Because see, from the previous slide we have seen semi-arid region, okay. Now maximum proportion of sand you will find in this, where you have the maximum, less rainfall, less vegetation, okay, less rainfall, less vegetation, and also deposition by water, by wind. You have desert location in this particular latitude. Clear? Now coral you will find in this region. Why? Because coral reef, the condition for its formation is very, it should be in the tropical waters only. The reason behind that we will discuss later. Mud will be maximum in proportion in this region, lower latitude, okay, and will be less in the higher latitude. Rock and gravel is less in this lower latitude but increases in the higher latitude, okay. This is how. Terrigenous mud, let us see. What is this terrigenous mud? Along the upper and middle continental slope, you will find this terrigenous mud. Clear? They are brought by bottom current. See, along the middle and upper continental slope, remember, I have already discussed to you regarding this continental slope. I have also discussed turbidity current, okay, the mode of motion of the ocean water, okay, in the form of current. So these particular terrigenous mud are brought by the bottom current, turbidity current. Now this particular terrigenous mud can be distinguished or can be classified. The first one is a black mud. Remember, these are very important term from your prelims as well as from your mains point of view. It is black mud. Why? Because you have high organic content and also less oxygen you will find in this particular black mud. These are the deposits, okay, you will find along the middle and upper continental slope, and these sediments are brought by bottom current. Remember, it may be from higher like continental shelf region. Blue mud, widespread in deeper area. It is blue. Why? Because of the presence of the ferrous iron, less oxygen, so oxidation did not take place, rather reduction take place, therefore in the ferrous form. It is not in a ferric form. Distribution you will find in Atlantic Ocean, Mediterranean area and Banda Sea. Green mud, in area devoid of large river due to the presence of green silicate of potassium and iron, gluaconite. They are known as green mud. Green mud because remember, green silicate of potassium and iron. Black mud, high organic content. Blue mud because it is in ferrous state, okay. Red mud because of the presence of iron, means oxidation is taking place, therefore presence of ferric iron, red mud. Presence of green silicate of potassium and iron, green mud. Blue mud means reduction, ferrous iron. Black mud, high organic content. Remember like that. Clear? Very important. So come here, green mud. South Africa, Japan, Australia, see, it is not like in other region you won't find this, but most prominent locations are in this region. Red mud, Yellow Sea, coast of Brazil, large area of the floor of Atlantic Ocean you will find. Clear? Turbidity. Come, let us see again once more. Due to turbidity current, changing in texture from coarse at the bottom to the fine at top. Topmost is clay, just below it you have a silty clay. It's like this. You see here, these are the turbidite deposit. This is a turbidity current. It flows like this, you see here. Now in all of this region you have this turbidity current, that is the motion. See, in the land area you have river and the river carries, but in the ocean the movement of the water is usually through this current. One of this that you will find in this area is known as turbidity current, and the important condition is in this turbidity current the heavier one settles down, a little bit lesser in size, means it is well created. Okay, well created means the largest size settle first, a bit smaller second, a little bit smaller, like this. On the top it is the clay, finest object. Okay, what is this contourites? They are contour currents, deep ocean, deep bottom current flowing over continental rise. Remember, continental slope region, you have this turbidity current. This turbidity current brought the sediments and formed this. Now, in the continental rise region, it is known as contourites, or contour current. Carry sediments brought down by the turbidity. In the continental slope region, it is the turbidity current brings down the sediments downward, and it is a continental rise. In the continental rise region, it is the contour current, and it is known as contourites, the deposit. Okay, and this contour current carries the sediment brought down by the turbidity from the continental slope region. Clear? I hope that is clear. See, a turbidity current is a rapid downhill flow of water caused by the increased density due to high amount of sediments. Turbidity current can be set into motion when the mud and sand on the continental shelf are loosened by the earthquake or collapsing slope or other geological disturbances. Clear? Like this you will find. Hydrogeneous deposit. We have already seen what is hydrogeneous. Material which is precipitated out from the ocean water itself. So it is derived from the seawater itself. Number 1, carbonate. Number 2, phosphorite, evaporite. You kindly look at the different types. Limestone type deposit, phosphorates, okay, in phosphate form in crust and nodules, salt and gypsum, that are the evaporites, manganese nodules. Monmorillonite, clay minerals, derived from volcanic material including volcanic ash and basaltic rock exposed in the ocean floor. You see here, philipsite, hydrous aluminosilica of calcium, sodium and potassium. You will find this in the Central Pacific Ocean basin. Clear? Anyways, evaporites, last point, in shallow sea you will find Dead Sea, calcium carbonate, means how the evaporates are precipitated out. NaCl will be the last to precipitate. Okay, like this. Calcium carbonate, okay, will be first, followed by this, that is nothing but the gypsum, and finally NaCl, because it has the highest solubility, so it will precipitate out the less. Clear? Anyway, we'll end the session here today. Okay, we'll end the session here today. We will take a summer Christmas vacation. Okay, we will take a Christmas vacation. We will meet next month, that is in the month of January. Okay, so in the month of January we will continue from where we have left here, that is from this manganese nodules. We will continue in the month of January from the Unacademy platform, from all in the Unacademy platform. On behalf of all of them and myself, I extend season greetings to all of you. A very warm Merry Christmas and a Happy New Year. Bye bye and take care.